Hello everyone, welcome to FSP&D Educational Series July session. This session will be presented using Teams live events and it will be recorded and uploaded to InfoZone. Please join with a USB headset, computer speakers, or KP-issue smartphone using the Teams app for audio. Please remember, there's no dialing phone option. Last but not least, submit your questions and comments through the Q&A panel and they will be addressed at the end of the presentation. We prefer you submit questions with your email information in case we run out of time so Travis can follow up after the meeting. Next slide. If you would like to receive AIA credits for attending today's live session, please email your request and AIA number to Malini Kramer. If you watch the recorded session, you may self-report your AIA credits directly to the AIA. Today's session is qualified for AIA HSW credit. Now hand over to you, Travis.
Thanks. So my name is Travis English. Thanks for taking a little bit of time out of today and joining us for this, for our education series for our consulting engineers and partners. Here's our learning objectives. What we're actually going to do today is talk about 3 white papers that our group, my group, published from about March until June of 2020. We actually published about 5 white papers, but we're going to talk about 3 of them. Hopefully last month you had access to the presentation that Sandy did on oxygen, so I'm not going to talk about that, but you can get a hold of it. If you didn't see that, I highly recommend you get a hold of that. So I'm mostly going to talk through our surge planning, then exam rooms, and the general reoccupancy white papers that we put out. I am going to talk about the HVAC industry. Most everyone you talk to outside of the HVAC industry kind of has a recurring theme that they'll tell you there's no real credibility to the idea of COVID-19 as a long-range airborne transmitted disease. But the HVAC industry is in a bubble where we are talking about airborne COVID and long-range airborne COVID sort of day in and day out. I'm going to try to talk about that in a sensible way. So we'll start off with a little basic theory. When we cough or sneeze or talk, we produce particles. Those are mostly tiny water droplets that vary in size between about 5 and 100 micrometers. There's 1,000 micrometers to a millimeter, so this is all very invisible. If somebody's sick, some of those water droplets will have tiny microbes inside them. Those microbes themselves are much smaller. They're as small as 0.1 or 0.3 micrometers. When there's a biological particle inside the water droplet, we call that a droplet nuclei. And sometimes the water evaporates and expels that droplet nuclei. At that point, the virus, the raw virus, not surrounded by water, is in the air. And since it's very small, it falls very slowly and can get moved around longer distances for longer time. So we call that an airborne or an aerosol. In some diseases like tuberculosis or measles, those aerosols can cause an infection or, in a new case, a significant distance away from the source. So right away, that droplet/airborne terminology is insanely confusing. This is one of my favorite articles in the popular press from Wired because it has that wonderful title. They say coronavirus isn't airborne, but it's definitely borne by air. And I love that. It points out sort of the false dichotomy of these definitions because droplets are for sure in the air. And if you're in the room with somebody and they're talking or coughing, then this thing is in the air. So you should be wearing your mask. This has really heated up in the last 2 weeks. On 4th of July weekend, there was a group of 32 scientists and 204 co-signatories that sent a memo to the World Health Organization called "It's Time to Address Airborne Transmission of COVID-19." The New York Times picked up that story, and then the internet did, you know, that thing that the internet does. For this presentation, I am going to use the term long-range airborne transmission. I'll always use that phrase long-range. Because the big difference here that I think for us HVAC people we need to differentiate is that variable of distance. It's actually distance and time, but you can think about distance, that's much more useful. So I always like to remember the history. William Riley did the experiment that proved tuberculosis transmission in air. And the way that he did it is he put guinea pigs in cages, and he ventilated those cages with air from a tuberculosis ward. So you got a patient that has tuberculosis. The guinea pig never touched the patient, was never in the same room as the patient, and could not have received a particle thrown by a cough or a sneeze or an exhalation. So the only path of transmission between the patient and the guinea pig was the air. And so the guinea pig got sick. Hey, it got it from the air. It's kind of a necessary conclusion. So when the WHO and the CDC and epidemiologists talk about airborne disease transmission, the variable they're really looking at are infections happening with distance and time. So can those particles float out of one room, turn a corner, and float into another room, and then cause an infection? Or for HVAC guys, can those particles float out of a room down 30 feet of ductwork and then cause an infection on the other side of that? And we do, by the way, know that COVID-19 can float around. It can float down ducts. There's even a study fairly recently that came out that showed COVID in an air handler. But we don't think it's ever causing infections as it's moving around. Or I should say, it's never caused an infection outside of the same room or been suspected of causing an infection outside of the same room. By contrast, for these classic airborne diseases, tuberculosis and measles and chickenpox, the answer to those questions is yes, they can, they have, they do move long distances, they do move from room to room, and they cause new cases. So far, COVID-19 has zero indication of that, never left one room, traveled to another, and infected somebody. It likes close proximity and shared spaces. So nobody is talking about long-range airborne transmission. And I do mean nobody, or nobody on the science side. Even the people who wrote that open letter to the WHO are talking about airborne transmission in the room. They're not suggesting long-range airborne transmission. So unless you're in the HVAC industry bubble, unless you're in a meeting of the American Society of Heating, Refrigeration, Air Conditioning Engineers, ASHE, we call them, then long-range airborne transmission is really not a suspect. And I want to take a second here and ask you to think a little bit creatively and imagine for a minute just how scary the prospect of a truly airborne disease is, like we see here, right? If we did find a new disease that could start in one room and move out into a corridor into another room and then cause an infection, that's a whole different level of terrifying, because social distancing doesn't work. If you live in an apartment building with common corridors or shared ventilation systems, your whole floor could get infected, even though you've never met your neighbor. And that is a whole nother level of scary. So bottom line here, so far as we know, excuse me, so far as we know, COVID-19 is not a long-range airborne transmissible disease, and we should all take a minute and thank God for that. All right, so there has been some confusing and mixed messages, particularly in February, but the WHO and the CDC official position today and since the first week of March are to use standard contact and droplet precautions unless there's an aerosol generating procedure. Kaiser has our own group of infectious disease docs, and they're in alignment with this. So KP, the CDC, and the WHO are all currently aligned, which is nice. There's a few weeks of my life where they weren't aligned, and that was a little weird. So what's an aerosol generating procedure? Well, certain procedures like intubation, mechanical ventilation have a risk of producing aerosols. And I did say risk. Again, nobody is saying that intubation does produce aerosols, but it can. To date, there's still 0 cases and 0 suspected cases of long-range transmission from room to room. And we only mitigate that risk when there are these AGPs happening. In fact, the clinical recommendation is to reserve your airborne isolation spaces for those AGP cases. So obviously, I spent a lot of time this year talking about this. This is the final slide from an internal presentation we did with my team and our facilities engineers in April. It's about a half-an-hour presentation if anyone wants the complete version. But in terms of particle physics, those long-range aerosols are very small, less than 5 micrometers. Droplets are larger than that. We treat those small particles like they are suspended in air because the settling time is more than a few hours. Droplets obey gravity. The bigger they are, the more they obey gravity. It's very important for HVAC people to remember the concept of capture velocity. If you have a particle in the air and you want to move it on purpose, you have to have some speed in the air. And for a particle that's heavy or has some initial momentum from a breath or a cough or a sneeze, you need a good amount of speed in the air to move that thing deliberately. Smartest thing we can do, If we know where those particles are being generated, is to remove them at their source with a local exhaust or a local cleaning device. Outside air and room air dilution work on small particles that are suspended in there. They really don't have an effect on droplets because those droplets are heavy. HEPA filters and UV systems will remove and kill particles, and particularly the very small ones, but with droplets, probably not, because we'd have to actually move the droplets over to the filter or over to the light, and that can be different. I know this is a tremendous busy slide with a million words on it, so if you want the longer version of the presentation, please let us know, we can follow up. So probably the biggest mistake we saw in March and April was exhausting HEPA filtered air. To explain what's going on in this picture, we're taking air from a room, passing it through that silver HEPA filter unit, and then dumping it out a window. This is the Kaiser ICU. I took this picture on March 14th. Fun fact, HEPA filters were invented in the 1940s as part of the Manhattan Project. So they're originally intended to remove nuclear radiation particles. So if you have like a nuclear reactor, or the bomb in the room next door, HEPA filters are designed to remove those tiny, tiny radiation particles. So yes, they handle small particles. Yes, they handle aerosol COVID-19. They're 99.97% effective. Once we've cleaned air with the HEPA filter, that is pretty literally the cleanest air mankind knows how to make. You can go to the top of Mount Everest and the air ain't as clean as the air coming out of a HEPA filter. So to take HEPA filtered air and dump it out of a window towards the 91 freeway is kind of a tragically stupid thing to do. And we did this a lot. And mostly we did this in the name of negative pressure. So let's talk about negative pressure. Negative pressure does one thing and one thing only. It prevents cross-contamination of the room next door. So it is a tool to prevent long-range transmission. This should start to sound repetitive, but again, to date, COVID-19 has never traveled in the air to the room next door and caused an infection. So negative pressure is a protection against something that's never actually happened. It's not really even suspected of happening. Negative pressure does not protect the staff in the room with the patient. If you're already in the contaminated room, congratulations, you're in the contaminated room. You better be wearing a mask. Negative pressure only protects the people in the room next door. If you learned one thing in this hour, learn to repeat that over and over and over again. Negative pressure does one thing and one thing only. It prevents cross-contamination of the room next door. But negative pressure became the mantra of the HVAC industry very quickly and very loudly. As early as mid-February, we saw demand rocket up for these negative pressure rooms and negative pressure room conversions. That screenshot that you're looking at comes from a webinar of the American Society of Healthcare Engineers. With hundreds of facilities engineers in attendance, they made negative pressure the absolute center point of the conversation. I did call the guy right when it was over and told him what I thought, but he wasn't particularly interested in my opinion. So that mantra got really loud in the engineering societies. Negative pressure, negative pressure, negative pressure, negative pressure. It was unstoppable, really. I think at Kaiser we have 50, 75 rooms like the one that I showed you just a second ago, which is to say that we probably spent somewhere between $1 million and $5 million on temporary negative pressure room conversions. That number could be as high as 10 million. Nationwide, it's easy to estimate that U.S. hospitals spent hundreds of millions of dollars converting rooms to negative pressure in March and April of 2020. That is not money terribly well spent, folks, and it's not over. All of those temporary negative pressure rooms are going to need to get converted back. So it's going to cost us more to take them out than it did to put them in, because now it's biohazard waste. So we're not done spending a bunch of money on negative pressure. Okay, so that was a very, very long introduction to bring us to our first white paper. First white paper that we published is called, surprise, Negative Pressure and HVAC Measures for COVID-19 Surge Bed Units. We got our disease docs clinical approval in March, which was right in the middle of our surge planning. We made it very clear that negative pressure is not required unless there's a room designated for aerosol generating procedures. We made it clear 100% outside air, 100% exhaust air are not required for surge units. HEPA filtering of exhaust and return is not required for surge units. We made it clear never convert an OR to negative pressure. The right way is, by the way, if you have aerosols in an OR and you need to protect workers in the hallway, then you keep the OR positive, but you build negative pressure anti-rooms at all the doors. So we had a couple hospitals look at proposals to do this. That's what that picture is. None of them actually did, and I'm grateful for that. We included this conversation about dilution ratio, and you can see it in the actual text of the white paper there. We called it EBDF, the exhale breath dilution factor. And this is a concept that we frankly made up, but it was very, very useful in communicating to the doctors and to the staff leads. Here's how it works. Human breath is about 6 liters per minute, which is 0.2 CFM. The maximum setting on a breathing machine is about 40 liters per minute, which is 1.4 CFM. Oh, sorry. So if you're in my office or an exam room with 90 CFM, then the ratio of the room air to the human breath is 450 to 1. And the ratio of the room air to the max on a breathing machine is about 65 to 1. In an OR, we have a whole lot more air. So the ratio of the room air to the exhaled breath is 6,000 to 1. The ratio of the room air to the max on a breathing machine is 1,000 to 1. So if we could explain that the air in an OR provides 1,000 to 1, 6,000 to 1 dilution, that tended to eliminate the concerns about safety of people in the hallway. So every time we were able to have that conversation with the doctors, the idea of negative pressure in the hallway went away. All right, here's the best idea from COVID-19. This is the gold medal, in my opinion. In the early days, we didn't know about this. We found this towards the end of March. So special thanks to Ken Mead at the CDC, who actually developed this product back in 2016, 2017. The plans are right up on the CDC website. If you haven't seen this, you type ventilated headboard into Google and it pops right up. There's do-it-yourself plans right on the website. You can deploy this with 0 modifications to the base building system. You take that exhaust from the ventilated headboard, pass it through a HEPA filter and put it right back in the room. You can duct it out in the hallway if you really want to do that. But you can just discharge it right in the room. So compared to some of the very intrusive and frankly very ugly things we saw people doing early on, this really is the best idea. These pictures are all KP. Our first mock-up was April 1st in Riverside. So since the first week of April and moving forward, this is my group's exclusive recommendation. If you are going to do an AGP room conversion today or in the future, this is the only solution that we endorse. And you can kind of easily see why. All of the other negative pressure schemes provide 0 protection for the healthcare worker in the room. They only protect the guy in the hallway. This arrangement is designed to capture potential aerosols at the source and then remove them. So it protects the guy in the hallway, but it's also removing contaminants from the space with a little bit of directionality. So there's some chance that it is actually providing protection to the folks in the room. Okay, a brief conversation about placebo pills. We absolutely had command centers and hospital CEOs and doctors and nurses saying, you know, I want 50 negative pressure rooms, or I want entire units at negative pressure. We need HEPA filters for all kinds of places. And we couldn't really address each one of those conversations outside of the surge plans. And we also found that it's wrong to discount the psychological. When you tell the nurse lead, hey, we just balanced all the rooms to negative pressure, they feel better for a minute or two, even if you lied about that. So we did have some allowances for placebo pills or psychological measures. Biggest example for us is digital controls. In some of our hospitals, we already have 100% outside air systems. We have digital controls. So by reprogramming the zones, you can convert rooms or floors to negative pressure. A good tech can do that with a few hours worth of programming. So we did endorse that. The white paper says, if you can do a quote controls only end quote modification, then go ahead and do that. And we did. I don't know if I regret this yet, but I'm getting there because we have some meetings later this week. The problem is when you tell someone, hey, we just balanced all the rooms to negative pressure, they go, hey, great, can we do that everywhere? Or can we set this up on a long-term basis? And that kind of calls the bluff. So you're like, well, actually, I don't know that we can. But to summarize this first white paper, the big emphasis of our first white paper was facilitate surge planning. My department, the architects that I work with, the planners, had this insane task. I remember one of our leaders saying, okay, it took us 50 years to get the bed count that we have in Kaiser Permanente. You have 60 days to double that. Go. And we did. We actually have surge plans for every hospital for those bed counts. So it's kind of crazy. But if my team, if engineering would have said, hey, you have to convert every room to negative pressure, you have to convert every system to 100% outside air, you have to do HEPA filters in every room, those surge plans would have become way more time consuming, way more expensive, way harder to execute. And so we need to be valuable, we need to be prudent, we need to be practical. And I think this white paper achieved that. White paper number 2 that we're going to talk about is negative pressure exam rooms. Our second, so this is reoccupancy of examination rooms and options to reduce wait times. Sorry. This came out in early May, clinical approval mid-May. As we started reoccupying clinics, we had this demand for negative pressure exam rooms or increased air changes in our exam rooms. In the worst case scenario, we had one region talking about, let's go into the medical office buildings and bump up all the air in all the rooms to 6 air changes per hour. And obviously that would be a huge problem because most of our buildings weren't built for that. So even if you could achieve that amount of air, you wouldn't survive the first hot day of summer. And of course, in doing that, you would double or triple your energy bill. It turns out that most of the conversation centers around this table. When you've had a suspect aerosol generating case in a room, this table ostensibly tells you how long you need to wait to have 99% or 99% reduction in those air contamination levels. I want to point out that this table is not rocket science. It's not actually science at all. It is, in fact, Algebra 2. The equation is right there on the screen. So if you have a calculator with the natural log button on it, you can derive this table on the back of a napkin in 10 minutes. By the way, if you turn your iPhone sideways, your calculator now has a natural log button on it. If you have a spreadsheet, you can derive this table in 2 minutes. The basic principle is that if you have contaminated air in a room, you're going to ventilate it with uncontaminated air and solve for how much time it takes to reduce those concentrations. And at this point, I want to say it's really, 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 really easy to test the wait time, to test the particle removal effectiveness of a room. I went out a couple of weeks ago and bought a particle meter off of Amazon Prime for $130, and I got it the next day. And you can take an inexpensive particle meter and a can of Aquanet hairspray and spray a room full of aerosols and then take measurements every 5 minutes, and voila, you just measured the particle decay rate of the room, and the measurement will in general be better. This equation is conservative because it assumes zero gravity. It's just a dilution calculation. In reality, when you measure it, once you get to 20 or 40 minutes, gravity has done a lot of work and a lot of those particles have settled now. So measuring it is a good thing. The guidance that we issued here is to act locally, not grossly. Don't change your whole building. Don't change all of the rooms. Change a couple of rooms. In Kaiser, with our planning group, our current rule is 1 room out of every 13. So you bring in a HEPA scrubber, put it on the floor, or you put a HEPA extractor in the ceiling, and you can get that done. 1 room out of every 13. This one is affecting our design program. Kaiser's been doing these negative pressure rooms or special purpose exam rooms for about 10 years, but up till now, we've always connected them to the house exhaust system. Depending on the project, this could actually be less expensive. So we're going to allow either on the new projects. And we're also very much encouraging validation. Those pictures on the right are from last week. And again, all you need to validate these is a $150 particle meter and a can of Aquanet hairspray. So, we told them, yeah, great, go measure it. And when you go measure the decay rate, then you can actually report to your staff lead, hey, with this thing running, the room clears particles in 25 minutes. Right? Okay, that takes us to our third and final white paper, excuse me, which also has the best backstory. So I've already said there's all kinds of talk about airborne COVID in our American Society of Heating, Refrigeration, and Air Conditioning Engineers. It's ASHE. What you're looking at here is the May ASHE journal. There was a column called Guidance for Building Operation During COVID-19 Pandemic. This is a monthly column by a monthly columnist. It's an expert opinion piece, so there's no experiment, there's no original research, just one HVAC expert's opinion, gets peer reviewed by 3 other HVAC people, and boom, there it is. It's published in a peer-reviewed journal. So very shortly thereafter, and I do mean a couple of days, maybe a week later, the CDC put this up on their website. This is an information page, I should say, for office buildings. And they included 8 measures for HVAC systems, most of which are taken from that ASHE column. Number 1, increased percentage of outside air. Number 2, increased total airflow. Number 3, disable your demand control ventilation systems. Number 4, use natural ventilation. Number 5, increase your filter efficiencies. Number 6, inspect filters for bypass. That's always a good idea, by the way. Number 7, consider running your ventilation systems all night, 24/7. And of course you go, oh my God, there goes your energy. And then of course the last one, create negative pressure zones, right? So now we want to create negative pressure zones in office buildings. So this put us in a rather crazy pickle. Obviously, as a building owner, we want to honor the CDC recommendations and follow their guidance wherever we can. But if you're familiar with HVAC systems, these have some pretty serious operating cost impact. And in a lot of cases, flat out feasibility issues, you'd need to invest a significant amount in your HVAC systems to get to some of these. So this brings us to our most recent and longest white paper. This one's 11 pages long, and it's called Building Ventilation Checklist for Reoccupancy. It came out in mid-June. We got our infectious disease doctor sign off in the middle of the month. What we had to do was to go through all the recommendations from the CDC page. We looked for the origin of it. We looked for the apparent evidence basis or rational basis behind it. What benefit could we possibly expect these measures to have on the spread of COVID-19? I'm gonna give a shout out to Taylor Engineering, Alameda, California, who has their own white paper on the website, which is the most citation-filled, rational, and evidence-based paper on the topic within the HVAC industry. So thanks to them. And our conclusions were that most of these recommendations could not be expected to yield any positive benefit because they are mostly based on the assumption of long-range airborne transmission, which of course, the official position of the CDC and the WHO is that long-range airborne transmission is unlikely. So we emailed the CDC, shared our assessment, asked about any other evidence or benefits they knew about or suspected, and they emailed back. We included that email thread in the white paper. So amidst 1,000 words of disclaimers, the CDC clarified that this is not a guideline, it's an information page. These are not intended to be requirements, they're recommendations for building owners to consider. So here's what we ultimately published. This is page 1 of what we distributed to our field teams and to our facilities engineers. Our emphasis is on validation. If you designed your building ventilation system well in the last 20 to 30 years and you've maintained them well and they're functioning to their intent, then do nothing. COVID is not a reason to overhaul or upgrade your HVAC systems as a general rule. The way the paper actually reads is that you go through this checklist, and if you're green, then you're green, do nothing. If you're yellow, then you call one of Travis's engineering team. So then that begs the question, if you call one of Travis's engineering team, what are they gonna tell you? Well, what we're gonna tell you is to measure your air. By the way, I know that you're giving an hour of your time here, so this is the one piece of advice that I'll give that's worth the ticket price. You will never get this piece of advice from ASHE, you'll only get it here. Measure the air quality. Go to Google or Amazon and you type PM 2.5 meter or PM 2.5 monitor, or better yet, handheld PM 2.5 meter, and you'll see a bunch of them up there for under $300. Don't buy one that just measures PM 2.5, by the way. PM 2.5 stands for particulate matter, 2.5 microns. You can also get one that reads PM 10, particulate matter 10 microns. PM1, particulate matter 1 micron, CO2 is carbon dioxide, VOC or TVOC is volatile organic compounds. By the way, if you have a 12-year-old son and you have a VOC meter, you can lock yourself in the car and determine who has the best farts. That's what VOC does. But the bottom line, measuring air quality is very, very affordable, and measuring air quality is kind of kryptonite to bad advice you can get from HVAC industry. Go measure your air. If your levels are good, then stop because your levels are good. Don't solve problems that you don't have. And by the way, the other piece of advice we have is if you do have air quality problems, the HVAC system very often is not the answer. You got to go look for the source of the problem. You have a source of particulates in your space. That's not the HVAC system's issue. And of course, if you are going to do something with your HVAC system, like add a filter, add a disinfection unit or something like that, then measure the air before, measure the air after, and make sure that it did what you wanted it to do, right? And that sort of leads into these last couple of slides here. So COVID-19 is not a long-range airborne transmitted disease. I think I've said that 100 times now, so hopefully that's sunk in. People in the same room with each other are the big transmission path, as well as everything they touch. And so that's why we're doing social distancing, that's why we're doing hand washing. And in epidemiology, they are essentially outright discouraging the idea of long-range airborne transmission. The WHO Myths and Facts webpage Is COVID-19 airborne? No! In other words, we do not want to freak out the public with this idea that this disease can move in the air from one room to the next and cause an infection. Even in the COVID wards themselves, those aerosols are only treated as a risk when we have those AGPs, the aerosol generating procedures. So even in the COVID ward, we're looking at very limited risk of long-range airborne transmission. Now I'm going to show you the next slide. I hate to say this, but I have to say this. It is 100% in the best interest of the HVAC industry to have a different message than that. These are just a few examples. I actually have a file full of HVAC industry stuff, and I'm sure you can immediately see the big contrast. Outside the HVAC industry, the message is no, it's not a long-range airborne transmission. You know, no on the panic, basically. But anybody in the HVAC industry, that airborne panic is already in full swing. We are embracing it. We embraced it 4 months ago, and we're just living there. We talk about airborne COVID all day, every day. You've got HVAC industry organizations, domestic and abroad. You've got trade journals, marketing materials from product sellers, design engineers, controls people, basically anybody on the planet who makes their living selling air purifiers or disinfectors or filters or humidifiers or HVAC controls or consulting. In other words, 90% of my Rolodex, we are talking about airborne COVID, and we're talking about it a lot. I get 10 marketing messages a day. I delete most of them, but sometimes they come to me from a hospital CEO and a regional director, and we have to reply to those. So we've had to do a little bit of hand slapping. I actually have an email pre-drafted that's called ethics, HVAC, and the COVID-19. And so when we get marketing material that's pretty clearly on the wrong side of the line, we can send that out. And believe me, I get the irony there. The man says that any human being talking to another human being about ethics is probably a hypocrite. That's especially true if one of those human beings is me. It's a very sorry state of affairs. But it's not just me. There have been some Better Business Bureau complaints. I actually have a pretty good buddy of mine who runs a sales office. I do not envy him that job. He talks about sitting down with a group of salespeople and saying, hey, listen, this is what you can say. This is what you can't say. That's a hard job, right? So here is what I think the facts are to the best of my knowledge today. Number one, COVID is of most concern in close quarters. You sort of hear these things. If you spend 5 minutes or 10 minutes in a room talking to somebody without a mask, that's probably an infectious dose. But long-range aerosol transmission is not the headline. It's not the sub-headline. Nobody, not even the people petitioning the WHO for redefinitions, nobody is talking about long-range transmission. And listen, it cannot be the HVAC industry that makes that claim about the nature of this disease, because our motives are so obviously compromised. Number two, we don't have any evidence that increased dilution ventilation reduces COVID transmission. Please go buy a handheld CO2 measure and use it. If your outside ventilation is poor, you should correct that, but that has nothing to do with COVID-19. And in healthcare buildings, we tend to already have a lot of outdoor air. When we've measured it, our data says we have plenty of dilution ventilation, and adding more is very, very unlikely to provide any benefit. Number three, we don't have any evidence that filters or air treatment, particularly in AHU systems, has any effect on reducing COVID transmission. If the COVID needs to leave the room and travel through the duct to get through a filter, that's obviously probably a hard no. Treating air in a room might work, but you have to remember things like capture velocity. And if you're going to try anything in the room, buy a particle meter and do before tests and after tests, with a can of hairspray. Make sure that what you're doing is actually having the effect that you want to cause. And then finally, there's this idea about relative humidity. Relative humidity at 40% to 60% might reduce COVID transmission by reducing its survival. This is the most science-based idea out there. It's championed by Dr. Stephanie Taylor. I'm skeptical of this in application. I live in the Los Angeles area, and in March and April of 2020, our weather was 40% to 60% humidity, about 85% of the time. So I have a real hard time believing that COVID-19 outbreak in LA could have been avoided by having humidifiers in all of our buildings. I do not think that is what Dr. Taylor is actually saying. but sometimes when her message gets repeated, it sounds like that's what she's saying, and that message morphs, right? So bottom line, if you're in this audience and you're not in the HVAC business, then thanks for hanging out for an hour or 40 minutes or whatever it's been. You probably have friends in the HVAC business, and I would ask you to please be empathetic to them right now. This is a very weird time. I'm not going to say that the HVAC industry is hoping for an airborne pandemic or wishing for an airborne pandemic, because that would be a really dark commentary on human nature. But if there were a bona fide airborne pandemic outbreak like tomorrow, everyone in my business would be in very high demand. We would get very busy. We would have an expertise that is very socially important. We become really active and make a ton of money in a short period of time while saving lives. So that's very, very hard to resist. If you're in the HVAC industry, life is complicated. I'll tell you, if I was still in consulting and a building owner came up to me and said, hey, I got $50,000 here, what should I do to my building, on account of the old COVID-19? I'd probably take his money. I don't know that I'd be able to say, listen, man, put that money back in your wallet. Don't give it to me, spend someplace else, because he's just going to go to my competitor and spend it with somebody else. In my current role, that is exactly the answer I'm giving to our facilities. We're saying, listen, put that money back in your wallet, go spend it someplace else. And if you really have a concern, go measure the air quality in your building and let's see what's up. But that's really easy for me to say because I don't make my living selling products and services. I make my salary being an effective buyer of products and services. So for me, I'm not at that conflict of interest. I can't really offer any advice to sellers and providers. There's a lot of people with purchasing power in Kaiser, and most of them don't have to ask my permission on things. If you are trying to sell things to Kaiser or services to Kaiser, I think you just heard what I want to say. But more than that, I guess I do have this point of professional pride, right? I don't like the idea of HVAC showing up on the internet myth lists, right? Drinking alcohol doesn't stop COVID-19. Adding pepper to your soup doesn't stop COVID-19. Spraying bleach on your body doesn't stop COVID-19. Rubbing your skin with sunflower oil or laying in the hot sun, they don't stop COVID-19. And air conditioning does not stop COVID-19. I don't want us on the list of things that people laugh at over the internet, but I've definitely seen some stuff in my industry folder that belongs there. And so, I don't know. That's all I have in terms of presentation material. As the questions have come in, I guess you're going to read those, Linda or Taylor, maybe?
Yes. Please submit your questions and comments through the Q&A panel. Well, again, we prefer you submit questions with your email information so we can follow up with you as needed. Also, the recording of this presentation will be on InfoZone. Okay, Linda, hand over to you.
Okay, here we go. First question, Travis, please summarize what is expected from facilities for opening our buildings. We've been told to perform CO2 readings, particulate readings with hairspray, and install MERV 13 filters, as well as ACH readings by zone, which is a huge task considering the number of spaces. Please address all building types, clinicals, dental, ASCs, and hospitals.
Yes, okay, so here's the actual, if you are a Kaiser Permanente facilities operations professional, here is what you should do. You go through this checklist. Are your outside air, I'll give you the best case scenario. Are your outside air dampers somewhere between 10 and 20%? Yes, check. Are your minimum zone quantities somewhere around 0.25? Generally speaking, that's going to be true. So you check yes. Does the building have any CO2 sensors in conference rooms? Most of our buildings, the answer to that is no. So actually, that one's reversed. Wow, there's a mistake in my white paper. Does the building have opening windows that you could prop open? No. So you're green. Do you have MERV 13 filters? Well, yes. Then you're okay. If no, then you would call one of my engineers. Have your filters been inspected to check for leakage and bypass? Hopefully that's an annual PM for you, so you should be checking yes for this. Do you have economizer controls that are adjustable? If it's no, then you do nothing. Most of our economizer controls are in the package units, and so you would do nothing with that. If you are yellow on any of these questions, you still are not, it's not an obligation to act. Your obligation is to call one of our engineers. That could be me, or based on what region you're in, it could be Ben or Maya or Sandy or Kuramoto. So you call one of us, we'll have a conversation about your situation. If your situation is thus where you suspect you might have air quality problems, then we're going to talk to you about going out and doing meters. And by the way, my engineers will go buy the meters and come out to your facility and do that sort of stuff. So please don't feel like you got to go do that to all of your rooms, or you got to do that alone, or anything like that. Again, the primary emphasis of this paper is that if you have systems that were designed well in the last 20 or 30 years, and they've been operated according to that capacity, you should be in the do nothing position. If you feel like you're not in the do nothing position, then please call us and have us talk you through there. Do not go out and buy filters, and please call us first. That's the way that it goes.
Okay, great. Next question. Is anybody on the clinical side of Kaiser looking at dosage of virus, i.e. concentrations of pathogens in a room versus host resistant, or the likelihood of transmission to a healthy person?
That's a larger epidemiology question. We have our lead epidemiologist who we have some interface with. I've had to have some interface with Dr. Witt based on all this stuff. And so they're tracking all those problems. I don't know specifically. I haven't heard anything about, like, I assume where you're going with that is it's always been said that like one molecule of tuberculosis can infect you. I don't know that anybody's figured that out with COVID, or that the epidemiologists are anywhere near that, or susceptibility. And so I don't know what all of our EPIs are working on, but I haven't heard anything about that.
Okay, great. Next question. Further to your point on ventilated headboards, Kisho Kankari's ASHE presentation today seemed to suggest that exhaust placement above the headboard was significant in mitigating the flow path of aerosols.
Okay. What I would do, so the one thing that I've learned in the that wasn't really a question, so I'm just going to ramble on indefinitely for a minute or two. The one thing that we've learned, I think, with this ventilated headboard testing is that the CFD models and stuff that I've always read, I'm not sure that they're accounting for gravity. And frankly, gravity is a huge help. When Sandy and I went into these rooms and sprayed it full of theatrical smoke or sprayed it full of hairspray, the particle decay rate that you would expect to get based on your ventilation alone, your particles decay a lot faster than that. And we believe that's because they're falling out. And so, so I would urge you, if you're going to go do this, it is cheap, and simple to go in there and test the thing. And then you can actually tell the doc, you go, hey, look, with this thing in this room and that filter running on high, this room clears in 12 minutes. And it's not theoretical, it's tested.
Okay, next question. HEPA filters remove 99% of particles whose diameter is equal to 0.3 microns. Corona particle sizes are 0.06 to 0.15 microns. Your thoughts on that?
There's actually some different information about the size of the coronavirus particle in nanometers. I think between 125 and 300, or I forget the numbers off the top of my head. But if you actually, I just happen to have the chart up on my screen. HEPA filters actually get more efficient as the particle size goes down. I don't know if you can sort of see that, but as you get towards those 0.01 or 0.02 particles, their efficiency actually rises, and there's some weird reasons for that, Brownian motion and things like that. But that is important to recognize. Again, I love the history of the HEPA filters. That they're supposed to remove alpha and beta nuclear particles so that you don't turn into a hole, but they are effective on small particles. I think we need to trust our HEPA filters, or better yet, don't trust them, test them.
Okay, great. Another one. What about in our restrooms where it is said that COVID can become airborne by flushing? What are your thoughts on that?
I haven't heard anything on the clinical side or the or the epidemiology side that indicates that that's, I'm not aware that there's any cases or suspected cases or anything that would indicate that that's something we need to be worried about.
Okay, great. Is there a cap on acceptable relative humidity for rooms with COVID patients?
No, generally well, I don't know, within Kaiser, generally we follow the 60% high-end range or 65% high-end range. I've always argued that 60 and 65% are a little moot because of the way that humidity sensors work and humidity control systems. But I think most of our spaces are controlled to that 60% limit, including office buildings and clinics and spaces like that. So if you have a building that's not controlled to a high end of 65, I would probably be concerned about that, but not because of COVID, because of mold and because of some other sort of standard issue IAQ issues.
Okay. ASHE has endorsed UVGI and mentioned in-room applications in the filtration position document. Has KP looked at this in any of their facilities?
We haven't looked at it at any facilities. We had to do an assessment. That's one of the other things that we did, is we had to do an assessment of that ASHE position paper and all the technologies within the position paper. UVGI is a weird thing. It goes in the room and it's high in the room. And so if you think about it, for the droplets, if you're talking about coughed or sneezed droplets, they ain't going up. They follow the rule of gravity, and so they're not going to go from the patient, up to the UVGI. So really, that is, again, that has to do with aerosol particles. I'm of the opinion that UV probably does what it says that it does. I have no reason to doubt that it'll kill whatever hangs out in front of it for a couple seconds. So I think the real concern is, can you get the particles up to the UV in order to have them killed? How do you drag those convicts to the electric chair in order to kill them?
Okay, next question. Can you confirm what is the diameter of the virus and how far the droplet will travel indoors?
I'm not the expert on either of those. I think, however, I will empathize that there's been a bunch of information and misinformation around the diameter of the virus and the sustained time. There is a bunch of that floating around the HVAC industry, which makes it very, very difficult. But again, what I would sort of empathize is that when we're talking about long-range airborne transmission, the way that an epidemiologist is going to determine that this virus has a long-range airborne transmission potential is a case, right? Where we would have a case where somebody's in one room, and then somebody in the next room gets infected without touching the guy in the original room or spending time in the original room with the guy. That's the evidence that creates the suspicion of the long-range airborne transmission. And there have been no cases, and there have been no suspected cases. Even the guys that are writing the WHO about redefining aerosol and droplet, which I totally agree, that terminology is as confusing gets. They're talking about in-room cases. So there's some really famous ones. There's a Chinese restaurant, and there's the Seattle choir, where there are big transmission events, and they all and it clearly points a finger at 6 feet might not be enough. But again, it's all happening within a single room. So that's really the big differentiator. If you're in the room and you're talking about doing something in the room, then that has a potential to be valid. I would validate what you're doing. If you're talking about something room to room, or having the COVID move 30 feet back to your air handler and hit the MERV 13 filter, then the chances that's going to provide any benefit are slim to none.
Okay, another question. If engineering wants us to increase air exchanges in rooms in a COVID clinic, should we tell them no, that's not necessary if they meet that list of qualifications?
Yes, that is exactly what you should tell them. And then send it, and feel free to send them my way. Most of our clinic buildings, if when we're out there building medical office buildings for the last 30 years, most of those are just office buildings. And so we have return plenums, and we might have even bought the building from somebody who was going to be an office building. And so So the idea, which I mentioned, which we had in some of our regions where they say, oh, let's go in and increase all the exam rooms to 6 air changes per hour. No, that's a big problem. You can't sustain that in summertime. You can't sustain that with your fans. You're going to triple your energy bill. All of those are outcomes that we do not want. So if your clinical client group is insisting on doing stuff to the air, please get us involved. And if anything, we would talk about that 1 out of 12 rooms and doing some local solutions for those and validating them as we put them.
Okay, next question. Is there a need to repurpose acute care med-surg rooms to ICU or make them hybrid?
Is there a need to repurpose med-surg to ICU? Well, we are, so let me answer that question twofold. When we did the surge plan inside of Kaiser, Linda worked on surge plans. And when we did surge plans, spoiler alert, that's how we do it, right? We have ICU beds, and then we take the med-surg beds and we repurpose them for ICU beds. And then when we run out of med-surg beds, then we go to the PACU and we repurpose those beds for ICU, et cetera, on down the line. Any bed that you can get a hold of, you call an ICU bed. But that mostly has to do with the medical services that are, or the staffing that's around there. And for us, the headboards, how much oxygen, nitrogen, and things like that. We did not tell our folks to change the air conditioning. If you're going to repurpose a PACU to an ICU, don't change the air conditioning. If you want to do something, do a local ventilated headboard or something like this, but don't go change the base building system.
Okay, here's a technical question. Hopefully I'm phrasing it right for you. The reoccupancy checklist seems in conflict with some of the conclusions. Minimum vent greater than 0.25 CFM/FT2 versus dilution ventilation. MERV 13 versus no long range, etc. Can you compare the checklist to the conclusions?
So for that, I'd actually urge you to read the white paper, because that's actually what the white paper does. The reason that it's so darn long is that we actually went one by one. We have this 4-page thing where we went through the CDC's, well, I don't think it's really the CDC's list of recommendations. They sort of got it and reprinted it. But we actually did go through each one of those, and we looked for the apparent origin of the recommendation, the evidence basis surrounding the recommendation, what possible implication it would have on COVID-19. And so we kind of went through that one by one and came to the conclusions. And so you can kind of see that we started with the list of those 8 recommendations, and we sort of boiled it down to our ventilation checklist, which is again more focused on validation. If your systems are working according to their design intent, the way that we've designed and built over the last 20 years, then you're probably okay. That was where we went with it. I hope that answers the question. If not, please hit me up by email.
Yes, they should send you an email, because we don't have their email information. Okay, next one from Brendan Burley. Can you comment on the placebo effect of HVAC improvements? I'm in the consulting industry, and I have told people to put their money into low context systems before HVAC, but many still want to say they have done something, even if we are unclear of its effectiveness. At what point does occupant discomfort become the problem you are addressing with HVAC improvements?
Well, I think that was 4 questions, and I know Brendan, so you can always call me, but so I'll try to go with what I remember. Look, the placebo effect, a lot of what's going on here is that air is this invisible thing, and it is frightening, right? And so we've all seen the Dustin Hoffman movie where he goes, "Oh my God, it's airborne," and it freaks you out. And so clinicians and doctors and our hospital administrators are not immune from having that same fear. We all are. And so I'm wary on the psychological measures. I told you we did some of that. We told our building engineers that, hey, look, if you can accommodate some negative pressure with your building controls, yeah, go ahead and do that, and tell them that you did that. But I'm having that come back and bite me in the butt 3 months later, because now they say, oh, you converted first floor to negative pressure. Can we convert the whole building to negative pressure? And so once you sort of set a precedent on a placebo pill like that, then you're bound to repeat. Well, I've definitely heard of building owners, not Kaiser, but I've definitely heard building owners doing exactly what your question said. Well, I know this isn't going to do any good, but I want to be able to tell my tenants that I did something. So let's install this widget into the whatever. We're trying not to do that. Organizationally, we're trying not to do that, or at least understand that my role is the National Director of Engineering Standards. So our engineering standards are never going to endorse that. We've had our facilities guys do it. We have some of that stuff going on. So I don't know. It's a tough question. Like I said, I know Brennan's the consultant. If somebody came to me and said, here's 50,000, go do something about COVID, I don't know that I would tell them to go put that money back in their wallet. I think, I don't know what to do, but I appreciate that you're thinking about it.
Okay, Travis, we've got about 4 more minutes and a few more questions. The first one is, where can we get your white papers?
Okay, that's why I know this invite went pretty broad and we tried to distribute it. We tried to get the invite out. The KP, our white papers are on our KP channels. And so if you are a consultant if you're a consultant or a contractor or a commissioning agent or whatever, architect that's doing business with Kaiser, then you have access to InfoZone. And I don't think these are posted on InfoZone, but we will post them on InfoZone, your supporting docs. And so they are available. That being said, if you're outside of Kaiser, then this is part of the Kaiser design program, part of the Kaiser internal program. But I'm sure that you have a friend who is a consultant to Kaiser or an architect that does work for Kaiser.
Okay, a question from Justin Opperman. Any pushback from space occupants when you switched from dumping HEPA exhaust outside and started discharging in occupied space?
I haven't heard that. No. I did have one doctor that sort of didn't trust the HEPA filters, HEPA filter efficiency, and so we had that conversation, and I was able to sort of send him that this diagram here about particle size actually comes from some CDC literature. But we had the conversation, and that issue sort of went away. So that's unfortunately what's happened. And it's kind of the HVAC industry shooting itself in the foot. We've had some folks come out and say, HEPA filters don't capture coronavirus. You have to use my special razzle dazzle widget to capture coronavirus. And so it's kind of like we're casting doubt on our own technology. But there was only one doc that I talked to that had any question in his mind. Most of the people I talked to, you tell them, hey, listen, this is 99.97, and that conversation is done. You can dump it right back into the room. Everybody's fine.
Okay, we've got some strong interest in this subject, and we'll try to get through all the questions. But if we don't, just send your questions directly to Travis. So we have at least 2 more. Our behavioral health providers are especially concerned with meeting patients in their office and its effect on air quality when they're breathing. It's difficult to maintain 6-foot distances. Any suggestion for increasing safety for our BH provider during this time?
I don't actually know. If you were going to put something in the room, it would be very loud. And so I don't know that you'd want to go there. You could put a local scrubber in the room. That would provide some level of protection. I would still tell you to be wearing a mask. I think anybody would still tell you to be wearing a mask if you're in the room with an undiagnosed. I think that's exactly the kind of thing that I would not recommend you make any changes to your base building system because they would only do placebo pills that wouldn't actually do you any good. So that is a tough question. Same with offices. It's not like there's anything we can do about conference rooms. It's difficult to sit 6 feet apart in conference rooms. So we just have to deal with that. That's the reality of the situation.
So Travis, we still have 275 folks on the line and a few more questions. Is it okay with you if we go through a few more questions and run over time?
I'm okay to hang out a little bit
Okay.
longer. Let's go ahead and
Let's do that. Can you comment on the placement of the exhaust in the ventilated headboards you have built? Some are above and some are behind the patient. Are there differences in effectiveness between these placements?
Not in terms of the particle removal in the room. I'm going to go back to that picture of the ventilated headboard. So, no, I can't comment on the difference in effectiveness. I think that's the correct answer because we didn't actually measure that. The way that we tested these things is we had the clinicians in the room, we had a theatrical smoke machine, and we sort of blew smoke in the room, and you could see that like the velocity going towards the pillow. So you could see the air going towards the pillow. And then Sandy and I hung out in the room and actually tested that removal effectiveness, with a particle counter and the smoke machine, and measured how many minutes it took in the room, et cetera, et cetera. But to say that I don't think we have any valid, differentiation between a top grill or a bottom grill or anything like that. And I don't know that that would be terribly relevant in terms of the overall effect of the thing.
Okay, next, can you speak to exposure in terms of concentration and duration required for infection and how that relates to aerosol versus droplet distance, et cetera?
No, I can't. That's the stuff that really has to do with the nature of the disease and epidemiology.
Okay.
There's some stuff out there that's floated around, but find the right expert for that.
All righty. This one's from Mike McDonough. A lot of them are anonymous, but this one isn't. What would you suggest we do in large rehab rooms where there are lots of people working out, stretching, etc.?
I think that guidance is going to be similar to gymnasiums. Same scenario. Your base building HVAC is not really going to do you any good there. I don't know that you could really do anything with air distribution. In that case, I would think that, like in dentistry, we are talking about putting local HEPAs where we can extract any potential aerosols from sources. But in a gymnasium where people are moving around, it's not like you can follow somebody around with a HEPA filter. So I highly doubt that an in-room HEPA filter scrubber would have any real effect. So if you're worried about transmission, I wouldn't go to the gym.
Okay, have you looked into an active particle control system such as Secure Air?
We did a whole experiment on active particle control in our South Bay Hospital. That's a research project we did with the Energy Commission. That results should be coming out later this year. The trick is that in the hospitals, our air is already 2-pass filtered, and so it's hard to even get a reading on particles. If you have a banded particle counter, then you can get a reading on banded. If you just walk in there with a PM 2.5 and a PM 10, those are both 0 in hospitals, man, because that air is already so super clean that it sort of defies the meter. And so in the hospitals, actually our science project sort of demonstrated that active particle monitoring is not really likely to do any good, because we're already, if you're already taking 10 showers a day, it doesn't really do you a whole lot of good to adjust that by 1 or 2.
Okay, great. It looks like we're in the final stretch here. We have 2. The first one is just a comment. Problem with the placebo effect, it creates overconfidence, so clinicians discard masks. We need to avoid placebo effect solutions, I think. That's a good comment.
I'm not going to disagree with that, yeah.
No. And then the last one says, I saw GPS needle point ionization listed on one of the slides. Do you have an opinion of its effectiveness at reducing COVID-19 A-zone level when applied in a VRF fan coil?
So I have reviewed, I won't say that product. I have reviewed the literature for that product. There are a couple of products out there that are of the nature of this ionization, and the value proposition that ionization is, the way that I understand it, is that you would put this ionizer somewhere in the supply ductwork, and the ions would attack any COVID that lands on a surface. And if you can bombard, like my desk here, you can't see what I'm doing with my hands. If you could bombard my desk with ionized air particles for a half an hour, then it would kill the COVID. So that's the value proposition that's being offered by those ionizers. I guess I have no reason to doubt that that's actually true. Whether or not that has any effectiveness in reducing the spread of the disease is a complete unknown, and I would say fairly questionable, right?
Okay, so that's the end of our questions. Taylor, I will send it back to you to wrap it up for us.
Okay, thank you, Travis. Thank you, everyone, for joining our session. We look forward to see you guys in August. If you have any further question, please email me or Travis. We will follow up as needed. And for the white paper, people have been emailing me now trying to find those white papers. So Travis, I will communicate with you whether how we're gonna distribute the white paper.
I know where we're gonna put those. I think we could probably make those available to. Well, I don't know. We'll talk about that offline.
Okay. Thank you, everyone. Thank you.